left, right, down, up. And that is working. Welcome back to Arcade. I am Super Tommy, and in this video we're looking at Kaboom.js and specifically top-down character movement and animations. So we've done a Phaser 3 dungeon crawler series, which has been very popular, and we're taking the same assets from that tutorial and using it here. Now, before we start, if you enjoy our videos, be sure to like and subscribe for more videos on game development in Kaboom.js, Phaser, and other web technologies. It is also the best way to support the channel. Let's get back to what we're doing here, which is making this top-down character movement and animations. So we're using Kaboom next to do the code in this video. So it is the bleeding edge version of Kaboom. Depending on when you watch this video, it may be the normal version. So what we're looking at is the version after sticky type. That's after version 0.5. So the syntax will be a little bit different. There's a bunch of changes in Kaboom since version 0.5, but we're going to talk about concepts here a lot, so you should be able to figure it out even if some of the functions have changed. Okay, so let's talk about sprite sheets. So what we're going to have is this faune character, and I think I'm still pronouncing it wrong, but that's how I think it's pronounced for this character. Now you can get the PNGs for this character on itch.io. Just search for faune, that's F-A-U-N-E, and then you'll find it there. We'll link to this in the description box below as well. So once you have those PNGs, you can run it through texture packer to create a single sprite atlas or sprite sheet. And so if you look here, we have that 0 and that 23 here. You can see 0 being the first frame and 23 being the last frame. So we've kind of put it into 3 rows, but your texture packer program may put it in 1 row and not 3. But either way, we're counting the frames from 0 to 23. Each frame is 16 by 16. So that's how these animations are created from each frame. So let's look at the walk animations. So we've got walk side, walk up, and walk down. So now we've color coded it here over there, as you can see, that the walk is the blue. And so in the blue is from 0 to 7. So those 8 frames make up the walk animation. And then for the pink walk up, that's walking while facing up or away from you. That's the pink line, and that's from 8 to 15. And then the last one, which is walk down, that's the yellow. That's from 16 to 23. That's the walk facing towards you animation. So this is a top-down character. You can walk left, right, up, and down. Now, this character will also stop. So in stop, we've got the idle animation. So now for this case, we're just going to pick 1 frame to denote the idle animation. If you're using different set of assets, your idle animation may actually have more frames. But in our case, we're just going to take 1 frame from the walk side animation, the walk up, and the walk down animation, and call them idle down, idle up, and idle side. So that's how we're gonna use. That's what we're gonna use for this this example for our top-down character animation. So now let's check out in the code how we can load the assets, create the animations, and then put it on screen and connect them to the arrow keys to move around. Okay, so we're here looking at main.ts. So yes, all the code is in TypeScript. If you're using JavaScript, just ignore all the typings. It wouldn't matter to you, but all the code will basically be the same. You can just ignore any typing that we do. So the first thing here that we have is we're going to load the PNGs that we need. So that's the faune sprite sheet. Now to start, we do have these arrow keys that we're loading. This is just for us to show you in this example when we are pressing those arrow keys. So you can ignore those. Let's come down here. We're using load sprite atlas. This is the key function from Kaboom that you need. And so if you've not seen our videos on Kaboom before, we are actually creating, so let's look here, a Kaboom context instance. So that's calling this Kaboom function, and this is importing the actual Kaboom from the actual Kaboom library. So this is the Kaboom context that we can get all the Kaboom functions that we need, and we import them here. And then we dereference, or we destructure rather, the available functions that we want to use like this with const and then equals k. So then you can also do, k dot load whatever, but we're just taking the functions out by themselves. So we don't have to call k dot. We can just call those function names by themselves. It's just a little bit nicer to look at. So let's come down here for the sprite sheet loading. So we're loading a sprite asset, sprite atlas, and it's going to be this file here. So that's this faune.png, and this is that sprite sheet that your texture packing program will produce. You can use Texture Packer or any other program to create one of these. And each frame, like we mentioned, is a equal sized 16 by 16 frame, and they're numbered from 0 to 23. So here, what we do is we say we're going to load the sprite atlas, and then with some configuration data as the second parameter here, we're going to say for the faune key, so this is going to be that sprite and animation set, where in that sprite sheet the animations start. Now, in our case, we only have one character in our sprite sheet, so we can start at 0, 0. That's the top left. So that's over here, the top left corner. And we're going to say that the width and height that we're going to be using for this animation sequence is the entire thing. We don't have any other characters here. If you did have other characters, you may have to set a different rect into your sprite sheet. Now we're saying there's 24 horizontal slices because we're only one row, and each one is 16 by 16. So there's a total of 24 slices, or index 0 to 23. And so for the animations, we're going to now define 6 animations like we talked about: the walk down, walk side, and walk up. Now walk down is going to be from 0 to 7. So if you recall, it's this. And then we're going to do walk side, that's 8 to 15. It's 8 to 15. And then walk up, that is 16 to 23. That's the last ones here. And then for idle, we're just picking a frame. That was the 1, 10, and 19. And so that's how we set up the asset to be loaded so that we can then use it. So now let's go to our scene. So we have our character movement scene here, and this is how we add the scene to Kaboom and then run it with Go. So let's look at our character movement scene here. So this is also very similar. Now these arrow key creations is what I was talking about before. We're just putting these in to help you see when we press the arrow keys on my computer here. So you can largely ignore that. So what we are going to do in this function, which is the scene, is create the character. We're going to then start the character in its idle facing down position. Then we're going to check for input on each frame to know what to do. So that's going to be the left, up, down, and right keys. So first, let's make our character. So let's do add. Now we are getting the functions from Kaboom over here, just like we did in main.ts. Now add takes an array of components. Now if you see these little helpers here, this comps here, this is from Visual Studio Code. It's a update they've added in a recent version. It is not turned on by default, but I did turn these on for myself because I think it's nice. Just like named parameters you may see in IntelliJ or other programming languages have this built by default. But I like to see what exactly I'm putting in to these functions. So anyway, so this is add. It takes an array of components. So the first thing we want is position. And let's just put our person here at width and height. So let's go width, height. So width, height, half. Width, and then height, 0.5. And we're going to do the sprite. So that's our sprite component. And we're going to call this faune. So this key is going to match up to this key over here. So that's good. Now let's start our character facing down. So play, and then we called it, I think, idle down. Let's just double check. Idle down. Okay. So now let's actually look at what this will look like. Okay, so we have our character here. It's there. She's not going to move. So this is those arrow keys I was talking about. Now if I press my arrow keys, you can see that it's moving, or that the keys are lighting up. So now we can go back to our code here, and we're going to want to add movement here. But also before we do that, let's add an origin center. So you think you saw previously that it was not exactly centered in the screen just because our origin wasn't at center, it was at the top left. So we're going to do that. It's good. Now, we want to check for input on each frame. So we do that with the action callback here. And we're going to give that a function. I'm going to put all this pre-indented comment inside my function, because we're going to do everything inside this action callback, which is called each frame. So we want to get whether each key is down or not. So we're going to do that with, let's just say left is the left key. And we're going to do is key is down, left. So that'll tell us if the left key is down, and we want that for the right, up, and down. So I'm just going to copy that over. So you're going to watch me type it. Right, so it's the same thing as the left key, but it's for right, up, and down. Now, when we are moving left, we're going to want to do a few things. So when we are moving left, if the left key is pressed and current animation is not walk side. So first, let's just look at if we're actually pressing left. So if left, this means the left key is pressed. Now, we only want to play our animation if it's not already playing, but let me just do this without doing that first. So if the left key is down, we're going to do dot play walk side. So that's the sidewalk thing, walk animation looks like this. And you see by default it actually faces right. It's going to face left. So to do that, we're going to do set flip. So font.flip x. We're going to say true. That's going to flip it this way so that it now faces left. And then we're going to move our person on the x-axis left, which is going to be minus. So minus equals some speed. So let's define a speed up here. Just say 2. And we call that speed. Okay, so now let's actually see what we've got here. Okay, so we've got our character. It's in the center this time. Now I'm going to press the left key. Oh, going to press the left key, and it's moving. But you see that the animation is not like, it's restarting every time. It's not maintaining the play. That's what I was talking about. If your current animation is already whatever you want to play, don't play it again. So let's go back to our code here. So let's move these comments back in here so where it makes sense. Let's do this one here. And then, so this is the flip comment, so that, you know, when you guys are reading this on screen, it'll make a bit more sense. Okay, so that's the left animation. Now for the right, up, and down, it's very similar. So I'm just going to actually copy some code here so that you don't have to watch me type out the other ones. You can do that yourselves. So here's that. The last one down here is going to be idle, which we are I'm going to put some comments here for what we're going to do for idle. Before that, let me just walk you through this right, up, down, left versions. So in the right one, so if the right key is pressed and we're not in the walk side animation, play that animation, then set flip x to false. So because in the animation, it already faces right by default. So we set flip x to false. Then we add speed to move right instead of subtract speed like we did for left. And now for up, we do the same thing with checking the current animation. If not equal to walk up, set it to walk up to play. And then we're going to subtract speed on the y because it's negative y moving up. And then for down is the inverse. If we're not in the walk down animation, play that. And then we're going to add speed to the y to go down. So now the interesting part comes to idle when not any of your arrow keys are pressed. So left, right, up, down is not pressed, right? All these ifs is, so if left false, else if right false, else if up false, else if down false, they're all false. So it goes to the last else here. And what we want to do is to get the direction from the last animation that was played. And you can see all our animations here have a similar style or format where it's some action, walk, for example, dash some direction. So we have walk dash side, walk dash up, walk dash down. So what we can do once we have no keys pressed is to take the last animation, split the string by a dash, and then get the last element in that array as the direction. So let's actually do that. So const direction is going to be cur_anim.split. I'm going to split by dash, get the last one. Now for some reason we don't have it, we're just going to say we are facing down. So let's just say we messed up somewhere and we named the animation just walk or something. So we don't have a dash to split on, and .pop will give us undefined. And so we'll just say, well, we don't know, let's just make it down. It's always good to have safety defaults. And once we have that, we can just do play. I'm going to create the idle animation using the direction that we have, which is going to look like this. So we know this doesn't change. Idle dash direction. So if it was side when the player stopped, it'll be idle dash side. If it was up when the player stopped, it'll be idle dash up. Okay. Oh yeah, so I already had some of that. Don't need these comments. Okay, let's actually give this a try. Okay, so let's go left, left, right, down, up. And that is working. So there you go. So that's adding character movement and animations. That's it for this video. We covered adding your character sprite sheet atlas so that we can load that and then define the animations for a character. In fact, this is what it looks like. So here we have it. You can move around. It's pretty cool, and it stops. And all that good stuff. Now, if you do enjoy our videos, be sure to like and subscribe for more videos on Kaboom.js, and game dev on the web in general is the best way to support the channel. Be sure to come back next time for more Kaboom.js videos. We've got a bunch planned, including pathfinding, top-down vehicle movement, and much more. So be sure to like and subscribe.